All right, and homework 5.9. We're solving differential equations. The first thing we're doing, this is the key thing of this unit, is finding the particular solution. I'll do one of these, make sure we know what's going on. We've got y prime equals y times e to the x. I'm going to rewrite this as dy dx equals y e to the x. And the first thing we always do, and this is the first point on the AP exam, is separating the variables. So the dx is going to come over here. The dx always goes to the right because it's dividing, so we need to multiply it. And the y's are all going to end up on the left. So dy equals, we're going to have e to the x dx. And then how do we get this y on the other side? Well, that's pretty easy. We're going to divide by y. We don't want to divide the dy, so we're going to just put 1 over y. So whenever we divide, we're going to do 1 divided by, and it just makes it a little bit easier to see what the integral is. Now, we do the integral on both sides. The integral of 1 over y, dy, is natural log, absolute value of y, equals, on this side, the integral of e to the x is e to the x plus c. We only need one plus c. There could have been a plus c here, but when you move it over, it combines with the other plus c, and it would just be adding more work. So the next thing we're going to do is we're going to solve for y. Natural log of something. To get rid of that, we do e to the power of both sides. And so we get absolute, this is just going to be y now, because this will be positive. So we don't need to worry about the absolute value. It'll go away because this is guaranteed to be positive. So e to the x plus c. This can be simplified because anytime you have two exponents adding, it can be rewritten as e to the x times e to the c, because when you multiply, you add the exponents. This is the same. And then e to the c is another c. So y equals c e to the x. This is actually c2, I guess I should call it, because it's not the same as this c. It's e to a c. This is a constant to a constant. It'll get us some constant here. All right. So this is our solved equation, and it goes through 0, 3e. So y is 3e when x is 0. So we get c equals c2 e to the 0. So that's 3e equals c2 e to the 0 is 1. And so e to the 1 is just e. So 3e, I'm going to write that right here. I'm going to go back up here. Sorry. 3e equals c2 times e. And if we divide both sides by e, we get 3 equals c2. So our equation was y equals 3e to the x. We just plug back c2 in where the c was, and that's our differential equation. Or that's our solution to the differential equation. All right, on the back, just do one of these. The velocity, it tells you dv dt, which is actually acceleration, is negative 2v plus 16 with an initial condition of v of 0 equals negative 50. All right, so again, we want to find what v is. So we're going to use separation of variables. It tells us that. We're going to put the t's on this side, the v's on this side. The only thing is I don't see any t's, and that's okay. The v's will still need to come to the left side. The t's will still need to go to the right side. Let's see how this looks. We're going to multiply by dt. So we're going to get dv equals something dt. And the t's need to be on this side. The v's need to be on the other side. Well, how do we get the v's to the other side? V's need to be with dv's. We divide. We're going to divide by v plus 16 because it's multiplying by v plus 16. So it's 1 over v plus 16. Again, don't put it with the dv. It makes it a little confusing. And what's left over here is negative 2. There's still a negative 2 dt. But we can do the integral of this. Here we need to use u substitution. U equals v plus 16. du equals 1. So we have a 1 there. And so it's just the integral of 1 over u. The integral of 1 over u is natural log of absolute value of u, and then we're going to substitute back in v plus 16 at the end. So this is natural log absolute value of v plus 16 equals, over here, the integral of -2, it's the antiderivative of -2, and the variable is t, is just going to be -2t. The derivative of -2t is -2, and there's a plus c there. Okay, so we can do e to the power of both sides. And just like the one on the front page, we're going to get v plus 16. The absolute value won't matter because e to this is positive. Just like on the front page, we'll get e to this plus this. That's the same as e to this times this. And we just end up with another c here. c2 e to the -2t. And so v equals c2 e to the -2t minus 16. All right, so this is our thing, and we have an initial condition. They always give us an initial condition to find the particular solution. V of 0 is -50. So v is -15 when e is 0, when t is 0. So e to the 0 is 1. c2 times 1 is c2. And so we get -34 equals c2. And so our final answer is, I'm going to write it over here, v equals, c2 is -34. -34 e to the -2t minus 16. Okay. Now, they bring in limits. Terminal velocity is defined as t goes to infinity, what does the velocity go to? Okay, so find the terminal velocity of the skydiver. So the velocity of the skydiver is this guy. As t goes to infinity, we've got e to a really, really, really big number, but it's negative. It helps if you know what the graph of e to the -t looks like. It looks like this. Or you could do it numerically. E to a negative big number means you're dividing by e to the 2t. And so as this gets really, really big, you get closer and closer to 0. -34 times 0 is 0. And so you just get, for the terminal velocity, you get 0 minus 16, which is -16. That's the terminal velocity. So the question is, how come this number is smaller than her initial velocity of -50 feet per second? So I'm not going to answer this question for you, but I would like you to think. There's a skydiver. She opens her parachute. When she opens her parachute, her velocity, she was heading towards the Earth, -50 meters per second, presumably. It didn't give us any units. And then once she's got her parachute open and time has passed, her velocity ends up being -16 meters per second. Should make sense that they're both decreasing, that she's going towards the Earth. But I'm going to let you guys come up with an explanation for why her terminal velocity, as time goes on, is less negative than her initial velocity. Good luck on the rest of your homework.